So the best way to do this question is to visualize or draw this out schematically. So x equal to 4 would be this vertical line. And then that's where the base falls on, BC, which is of length. So it could be, say, here. C could be here. That length is, let's say, 8 units. Now we're given the area, so we can figure out its altitude. We can consider BC as the base. And you will see that the altitude is 8. So that means that the perpendicular distance, I mean, the altitude could be that has to be 8 units, which means that the altitude can be anywhere on this line, x equal to -4, because that's 8 units away. So for example, it could be here, A, in which case this is what our triangle looks like. It could be here, then our triangle looks like this. It could be right here. Could be like that. And this can slide too. But the key thing is that the x coordinate of that is -4. We're looking for the least amount of distance from the origin. And that means that that would happen when it's the straight line distance, meaning it is right on the x-axis. And the coordinates are -4, 0. And that distance would just simply be 4, because that's the straight perpendicular distance, whereas all of these are from the vertex to that would be much longer. So the answer is 4. Now, a lot of students might also do it by symmetry, saying that, let's say this is 4 and 4, that's your base. This is 8 units. And we'll draw this isosceles triangle that does have an area of 32. This distance is 4. And that clearly just right away eliminates these two. That's greater than 4 as well. It's between these two. And you can then go on with this argument. But if you don't have time, you can still narrow it down to just these two. So there are different ways to go about it. But of course, doing it in this more general way will assure you that that is indeed the answer, that there's no other possible way that you can have a shorter distance. So the answer is C.